Welcome to this training video about the three MEDINA components: Cloud Evidence Collector, Security Assessment, and Orchestrator. This presentation is divided into 4 parts. First, it gives an overview over the purpose of the components and their role in the MEDINA framework. Second, it shows how to use them, including a short demonstration, and how to install the components. Finally, further information is given to follow up on MEDINA resources. The MEDINA framework aims at supporting continuous security certification of cloud services. It focuses on the European Cybersecurity Certification Scheme for cloud services and the requirements it defines. Typically, such certifications are conducted infrequently, for instance once a year, as they involve considerable manual work. The components that have been developed in the MEDINA project support the automated and continuous checking of the respective certification criteria. The Orchestrator and its closely related components Security Assessment and Cloud Evidence Collector play a central role in this framework. Let's start with an overview of what their purpose is. The Cloud Evidence Collector collects evidence using Cloud APIs, such as configurations of virtual machines and storages. For example, it can query APIs of Microsoft Azure to obtain descriptions of the virtual machines that exist in a certain account. It then enriches the evidence with ontological information, assigning each resource description to a generic cloud resource type. We go into more detail of this ontology in the following slides. The evidences are then stored with the Orchestrator and are accessible via the Orchestrator UI. The cloud resource ontology is divided into a taxonomy of cloud resources and a taxonomy of their security features. A network service, for example, is a cloud resource and it is a child of the networking node, which in turn is a child of the cloud resource node. Additionally, it offers the security feature transport encryption. This feature is a child of the confidentiality features, which in turn is a child of the security features node. The Cloud Evidence Collector requests information about cloud resources from the respective APIs and enriches the data with appropriate ontological information. In this example, information about an Azure virtual machine is obtained and its resource type from the ontology is added. In the next slides, we will see how this information is further used to allow the creation of generic, reusable metrics in MEDINA. The security assessment receives the evidences from the Cloud Evidence Collector and assesses them using predefined metrics. The metrics are retrieved from the catalog of controls and metrics. To assess an evidence, available metrics are checked regarding their match to the resource type, and then their expected values are checked against the evidence data. The assessment results are then stored via the Orchestrator and are accessible via the Orchestrator UI. In this slide, you can see a simplified metric definition. It defines the ID of the EUCS control it pertains to, the control description, a metric ID, the scale of possible values, the operator for comparison, the target value that is expected in the evidence and is thus considered compliant, the target value resource type the metric applies to, as well as the matching security feature from the ontology. This metric shows that in MEDINA, metrics can be defined in a generic way using the ontological resource types and security features, rather than writing specific rules for the resource types and security features a certain cloud provider defines. The Orchestrator is at the heart of the MEDINA framework. It receives, forwards, and stores evidences and assessment results, and it offers many interfaces to other components, such as the catalog of controls and metrics and the continuous certification evaluation. The Orchestrator and the information it stores are accessible via the Orchestrator user interface. Here, you can see the complete MEDINA framework, including the 3 components we have just seen as well as their connections to other components. Here is a complete list of the interactions of the Cloud Evidence Collector, Security Assessment, and Orchestrator with other MEDINA components. See also the other training videos to get more information about these components. Let's now look into more technical functionalities and a demo. The evidence collection can be performed for Microsoft Azure and Amazon Web Services. There are also experimental additions for Kubernetes and other systems. Evidences are enriched with ontological information as described earlier. The Cloud Evidence Collector is written in the Go programming language and can be deployed easily as a separate container. The security assessment obtains metrics and their configurations, e.g., currently configured target values, from the Orchestrator. Metrics that match the ontological information in an evidence are applied to check if the resource conforms to the expected conformity state. The security assessment is also written in Go and can be deployed as a separate container. The Orchestrator allows users to manage many of the basic data objects in MEDINA: cloud services, targets of evaluation, evidences, assessment results, etc. It also manages many functionalities behind the scenes, forwarding assessment results between security assessment and continuous certification evaluation, updating metric target values, and so forth. It is also written in Go. The three components are based on Clouditor, which is an open-source project developed at Fraunhofer AISEC. The Orchestrator's user interface allows users to interact with the Orchestrator, which we look into next. This is the start page of the Orchestrator UI. It shows all the cloud services that have been configured. To create a new cloud service, click on the Add Service button, enter a name and description, and click Save. Then, you can click on the new cloud service to see further information about it and configure it. The most important configuration concerns the target of evaluation. The target of evaluation tells the MEDINA framework for which certification schema the cloud service should be evaluated, for example the EUCS. It also includes detailed information about which controls should be monitored. When the target of evaluation is saved, it is therefore propagated to many other MEDINA components. The other tabs allow to see information about the discovered resources in the cloud service, the metrics and how they have been configured for that specific cloud service, as well as the assessment results that have been stored for that cloud service. On the Metrics tab, all available metrics can be reviewed. Click on the Show Code button to see more information about the actual code that is applied to assess a certain metric. The Catalogs tab shows the configured certification criteria catalogs, and the Certificates tab shows the certificates that have been created. Let's now review some installation details. To build one of the components, make sure Go is installed and simply use the Go generate and Go build commands as stated here. Also, some environment variables should be set, for example to configure the cloud service for which the evidences and assessment results should be collected. As mentioned earlier, the components are written in Go and the Orchestrator can either use an SQLite or Postgres database. There is lots of further information about the MEDINA project. The MEDINA website contains the public deliverables, scientific publications, as well as many other useful information. Our YouTube channel comprises more videos, especially for training. The MEDINA Zenodo community and the source code repositories also hold documents and source code for further reading and development. Thank you for watching this training video. Goodbye.